For right pyramid, the volume can be derived using the general formula 1/3 area of the base times height. So for pyramid, the base can either be square, it can also be triangle, it can any be of the polygon that we have. So that is why we have area of the base, because if it is square, so the area of the base will be a squared. If it is triangle, 1/2 base times height times the altitude of the pyramid. This is the perpendicular height of the pyramid from its maximum height to its base. So the lateral area is the sum of all the face area. So this one is a face area. So those are your face area. Then we have the surface area is the lateral area plus the area of the base. So it includes the base of the pyramid. For the FRUSTUM of a pyramid, so the volume is 1/3 of the height. So the height, this should be perpendicular height, times the quantity, the sum of the area of the base at the top, plus the base at the bottom, plus the square root of the product of the two base. For the FRUSTUM of a cone, the volume is pi over 3 times the height, so this height, then the radius of the lower base squared plus the product of the radius of the lower base and the upper base plus the square of the radius of the upper base. Then we have for the volume of the sphere, the area of a spherical LUNE. So our theta should be in radian. Dapat naka-rad. Theta is the angle between these surfaces. For the volume of the wedge, this is not area but volume. The volume of the wedge is pi r cube theta over 270. Wedge is the volume bounded by this one. So it looks like when you cut a watermelon, so it's the wedge. So the volume of that part is pi r cube theta over 270. Theta should be in radian. So let's have some sample problems. So given a triangle of sides 10 cm and 15 cm and an included angle of 60 degrees, find the area of the triangle. So we have two sides and an included angle. So we have a triangle with two sides 10 and 15, and the included angle between them, so meaning between, it's 60 degrees. So the shortcut formula is just 1/2 the product of the two sides and then the included angle between the two sides, the sine of that included angle. So substituting the value, so we have 64.95 meters squared. Number 2, in triangle BCD, BC is 25 meter, CD is 10 meter. Find the perimeter of the triangle may be. So what could be the perimeter of a triangle? So we have a triangle BCD. So we're given with BC, that is 10, CD 25, and then we don't have the value of BD. So what could be the perimeter of the triangle? The perimeter is just the sum of all the sides, so meaning BC plus CD plus BD. But we need to find BD first. To find BD, since you don't have the value, the the possible value should always be less than, by squares inequality should be less than the sum of 10 and 25. So because of squares inequality states that the sum of two sides, so the sum of two sides must be greater than the third side. So if we have two sides A plus B, the sum of two sides, any two sides, should always be greater than the third side. So the two sides here are 10 and 25. So that's 35. So we look for numbers that are lesser than 35 to be the value of C. So the maximum value is, that is still less than 35, is 34. That's why we chose PD as 34. Thus the perimeter, the sum of all the sides, 69 meter. The sides of a triangle are 8 cm, 10 cm, and 14 cm. Find or determine the radius of the inscribed circle. So the circle is inscribed in a triangle. So we have a triangle. Inscribed is a circle. So we wanted to find the value or the radius of that circle. So what is the radius of the circle? So we're given with the sides, that is 8. The sides of a triangle are 8, 10, and 14. So using our formula, the area of this triangle is equals to the radius of the circle times the semi-perimeter. Since we don't have the area of a triangle, but since we have this formula, this is your Heron's formula. So using this formula, we can still find the area of a triangle using the sides. So using this formula, all we have to get is to find first the value of the semi-perimeter, which is the sum of the three sides, so 8, 10, and 14, half of the sum. So we have 8, 10 plus 14 divided by 2, so that's 16 cm. So our semi-perimeter is 16 cm. Substituting this one in the Heron's formula, where A, B, and C are the sides of the triangle, then we can get the area of a triangle, that is 16 square root of 6 cm squared. Thus, the radius of the circle, this is the radius of the circle, area of a triangle divided by the semi-perimeter, so 2.45 cm. The sides of a cyclic quadrilateral are 3 meter and 4 meter. Solve for the radius of the circumscribing circle. So we have a cyclic quadrilateral. So we have a circle. We have a circle, and then inside the circle is a cyclic quadrilateral. Circle. And then we have a cyclic quadrilateral. The quadrilateral has 4 sides. It doesn't have to be a perfect square. So the sides are A, B, C, and D. So we wanted to find the radius of the circle. So to find the radius of the circle, we will use this formula by Brahmagupta's formula, that the radius can be determined using this equation. But we need to find first the value of the area, because A, B, C, D, these are the values of the sides of the quadrilateral. But for the area, we can use this formula. So for area of a quadrilateral using the sides A, B, C, and D, all we have to do is to find the semi-perimeter and then substitute in the equation. Then we can get the area. So once we have the area, substitute it here, so we can get the radius, 2.5 cm. The rhombus has diagonals 32 and 20 inches. Determine its area. So for rhombus, so it's like a square. It has the same sides. All sides are equal. So A, B, C, and D, these are all equal. A is equals to B equals to C equals to D. We wanted to find the value of the area. So for rhombus, the intersection of the diagonal is 90 degrees. So if you're going to look at this formula, so we can actually find the area as one half of the diagonal 1, the product of diagonal 1 and diagonal 2. So the product of diagonal 1 and diagonal 2 divided by 2. So that's why we have 320 inch squared. For the area of a rectangular octagon, so this is an octagon inscribed in a circle of radius 10 cm. So we wanted to find the area of a regular octagon inscribed in a circle. So meaning the octagon is inside the circle of radius 10 cm. So the shortcut formula to find the area is 1/2 NAB sine theta. Why is it so? So for octagon, so if you're going to look at the octagon inside a circle, so this is our octagon. So these are the sides. So you have 8 sides. So if you're going to divide octagon into triangles, we can actually form 8 triangles. Triangle 1, 2, 3, so on and so forth. There are 8 triangles. If you're going to examine one triangle from that 8 triangles, each triangle, the angle of each triangle, you can get it by dividing. Since the whole is 360 and there are 8, 360 divided by 8, so that is 45. So each of the angle, this angle, central angle is 45 degrees and the side is given, so that is the radius of the circle, that is 10. So each side is 10, which is familiar to us, which is the area of, we can find each area then multiply it by 8 so that we can get the whole area of the octagon. So that is 1/2. So the sides 10. So basically it's what we have here, 1/2 10 times 10 sine 45, then the number of triangles, which is 8. That's why we have 282.84. Find the area of a regular pentagon whose side is 25 and the apothem is 17.2. So what is an apothem? So we have a pentagon whose side is 25. So this is our pentagon. It has 5 sides. The apothem is the perpendicular height from the center of the circle to the side of the polygon. So that is what we call the apothem. So to find the area of the pentagon, it's like also just like what we did a while ago, that we're just going to count all the triangles that we can get out of the pentagon. There are actually 5. Then analyzing one side only. So what is the area of this one side? That is just 1/2 base times height. So 1/2 the base, 25 meter, and the height 17.2 meter times the number of triangle, which is 5. That's why we have 1075 cm square.